My name is Ondrej Mirtes. Thanks for coming to my talk. I'm from Prague, Czech Republic, so it's very close to here, so I had a short drive. And today, I would like to show you how you can perform migrations and deployments without any downtime, so you don't have to show this icon on your website anymore. My experience comes mainly from working on big Czech e-commerce website called Slevomat with daily deals, and we have over 300,000 daily visitors. And despite of that, we can deploy our application between 10 or 30 times a day without any downtimes. My talk will not be about any specific tools, but only about fundamentals. So you can make informed decisions and choose the right tool for the job. My tips and workflows don't require any big changes to the code. So when you come back to work on Monday, you can start immediately benefiting from things I will tell you today. But I would like to start with the question, why? Why should we care about migrations and deployments without any downtime? Well, sure, if you are deploying only once or twice every 2 weeks, your customers can survive an hour or two without your website, probably. But I would like to persuade you that you should deploy more often. The number one thing I recommend to companies is that they should focus more on quick feedback. They can benefit from finding out as soon as possible that their proposed solution works. And I mean technically, that the developers don't have any bugs, that there are no errors on the server, and that the servers can sustain the load. And also from users' point of view, which means that the application has good user experience and the users are not getting lost when they try to achieve something in your user interface. So the sooner you know that you are on the right track, the sooner you can change things in the right direction or keep going. So you should verify as often as possible that everything works as intended. So who heard this in their lifetime? Let's rewrite it from scratch. So it happens from time to time that someone comes up with this idea, let's rewrite it. And it probably leads them to the fact that you have technical debt and you have made bad decisions in the past. And sometimes it's just because there are some more modern technologies available and you want to try out the newest PHP or JavaScript framework. And sometimes a new team takes over a project and they don't understand the current solution, they don't want to understand the current solution, and they just want to create a new one. But the current solution needs to be respected because it works and it makes money. And also closing the gap between the old solution and the new one can take years, and you will still have to maintain the old one meanwhile. And the result is not certain. So even if you manage to finish the project, you cannot be sure that you will end up with something better because you are developing the project on the side and you are lacking feedback from your technology and from your users. And once you're finished, the project might no longer be relevant to business because the business moved on and their needs might have changed. But why am I talking about this? My point is that complete rewrite is just one possible point on a scale of different approaches. So on one side, you have a complete rewrite that can take multiple months or even years. And on the other side, you have your code reaching production the same day that you've written it, which is really great and really motivating. But most of us, including me, are somewhere in the middle. So it means that you are repeating the same mistakes even if you are not rewriting your application from scratch. You are not seeking immediate feedback from your users and servers. You are developing it on the side, and your work can take days or even weeks before it reaches the production. And meanwhile, you are working on the side in some kind of feature branch. You are neglecting the version in production, and the needs of your users are not satisfied. They might need to live with some bugs before you can fix them. And once you are ready to merge your work into master and deploy it, you might end up with giant merge conflicts, or worse, you will realize that you will have to throw your code away. And once you deliver it, it will be full of bugs, and the customer realizes that he needed something different, or the priorities might have changed. So the longer you are going without feedback, the worse is collision with reality, and the bigger risks are you taking. And you are also getting further from real requirements. And when you release your work all at once, it will probably require downtime because you didn't plan ahead with the deployment and release strategy. And once you do your big release, there's a lot of changes, a lot of surprise for users, and some use cases of your users won't probably work as intended. And also because of your big release, the whole company stops, and it needs to adapt to the new version of your application, and they will be busy reporting bugs back to you, and you will be busy fixing them. So that's why I advocate smaller releases. You can release less changes at once, and they are so easier. The bugs are also easier to find and fix them, because when some errors start appearing in your logs after the deployment, you will probably know where they come from. But if you do a big release of tens or hundreds of thousands of code or lines of code, you will probably not know where the bugs come from. But when you release a small 50 lines pull request, it's much easier. So I'm saying that you should deploy new versions more often, and the quality of your software suddenly increases, and you can fix your bugs faster. The software suddenly starts meeting users' needs, and the users are responding back to you with feedback, and you are building on that feedback many times a week, improving user experience for them. From my experience, the most precious feedback comes from production. So you can put test versions of your application in front of your users with some testing data, but this testing session will not be taken seriously, because the users might click through your application, they might know that everything is okay, but once they start using your application for real in production, they start finding real issues, and that's the moment when they start taking the work seriously. So it's better to release to production as often as possible, because you will get real feedback from users, and you will know for real what to focus on. Another reason not to have downtimes is money. When you are running a local service in a single time zone, you can probably find a time with a minimal impact, probably somewhere around midnight. But there still will be negative impact, because someone will want to buy something from you during your maintenance window. And it's not possible at all to find a downtime window when you are running a global service in multiple time zones. So that's why I don't recommend having downtimes at all, because they will still get noticed. And also, deploying more often doesn't mean that you will have more downtimes. Performing a downtime means that you will have to stay up probably all night, and you are going to be sleepy, and you are going to make mistakes. So it's very risky. And also, a process that you are not doing very often isn't battle tested, and it's more likely that something will go wrong. Because if you are doing something once a month, it will not be as reliable as something that you are doing every 30 minutes, because it's more battle tested. I have a real story for you. A few years ago, we set out to improve our downtime process, because we are still doing downtimes because we didn't know any better. And we wanted to make sure that nothing uses the database. So we disabled all entrances to our application. We modified index.php to show a maintenance page with an estimated time when the application goes back up. And we modified our CLI.php that handled our crons and other commands to immediately exit, so that nothing accesses the database. But what we didn't realize is that CLI.php handled parts of our deployment itself. So we weren't able to deploy a new version under maintenance. And that's because we made this modification, and then we and then we wanted to use it something like a month after, but we didn't realize the side effect. So with this approach, we weren't able to have a downtime at all. So I think the lesson from this is that the best downtime is no downtime, which is actually what we should have optimized for instead of trying to improve the experience or the robustness of our application at the downtime. And going into maintenance mode is a little bit like going to the dark side of the moon. No one can help you there. Your communications are cut off, and there's a lot of pressure put on you, and everyone is waiting for you to come back online. And that's why you should be able to deploy and maintain your application without any downtime. OK, so that was a little bit of an introduction. And now we are getting to the main topic of database migrations. So when you are working on some new feature or a change, you will probably need to modify the underlying database schema. In an ideal world, we would synchronize the process of migration and deployment. But unfortunately, that's not possible because it takes a different amount to do each. This approach requires downtime because we need to take down the application and wait for the database migration to complete. So it's not possible to do those two things at the same time. The key is to decouple migration from deployment and make them independent. So the old version of the application that's in production must still work with the new database schema. That means that the migration needs to be backwards compatible. And it's important to realize that the database and the application run on a different life cycle because the deployments of the application of your code are almost always guaranteed to work and take about the same time unless you write a lot of new code. Then it takes longer because it takes longer to copy the files, for example. But migrations are more difficult. You can migrate tables with different sizes and with different loads, so it's not very predictable how long a migration will take. And also migrations can fail and they can lock some tables. So you need the ability to kill them and try them again more often than deployments. So with this approach, it's very safe, and if there's a bug in new version of the application, you can roll back again to the old version and it will still work because the new state of the database is still compatible. And this is also the same reason why you don't need migration rollbacks at all, because each step is small and safe and there's no risk involved, so you don't have to roll back your database to the previous version. So when writing a migration, you can write only the forward direction. The backwards direction is not always possible, and you also don't need it if you follow my advice. So I will go through a list of things you can actually do to the database, and it's important to split the migration into multiple small steps, as small as possible. And you should also think about the deployment process during development of the feature. So when you are writing new code, you should think about how it affects the current version into production and how you will migrate the current version to your new code. So that's important. It's important to split the work into multiple stages, and each stage will be deployed separately. And we are doing each step of the migration while thinking about the application. And with this way, there is little probability that something will break. So first step of adding a new column is to add a nullable column. And it looks like this. The last two lines, algorithm in place and lock none, they make sure that nothing gets locked in the database. So your application that uses the database will work continuously as it's intended. And if it's not possible to migrate to run the alter without locking a table, with these two lines, the database refuses to do the alter. So you will know if it's possible to run it without downtime. This works in MySQL 5.6 or later with InnoDB engine. If you have some other database engine like PostgreSQL, you will probably have less problems than in MySQL. And this approach always works no matter how big the alter table is. It might take longer, it might take several hours with a big table, but it will never lock it, and your application will still run without a problem. Okay, so this is how our table looks like in the beginning, and let's say that we want to add information about user's gender. So this is how the table looks like after the first step. The column is nullable, so that means that the inserts from the old application version still work, because they don't reference the gender column, but the column is optional, so it doesn't need to reference them. The next step is to deploy new version of the application that can write to the column. So we go from this state to this one. New rows in the table are inserted with a value, because probably your users started to filling out this value during sign up. So it doesn't mean only that the application starts writing this value, but also that you can probably require it in your user interface, in your web forms. Next, we can run a migration that fills in past data. This step applies in case you plan all rows to have the value for the value to be required. And this migration can be either an SQL query or it can be a PHP script. And we go from this to having all the values filled out. We could have probably guessed the gender based on the first name, and in case it's ambiguous, we can probably add another value called, for example, unknown. I recommend explicit unknown values instead of null, because it forces you to give the value a name and express its meaning. Because null would probably you cannot be sure what null means. It can mean that the user registered before you start requiring the value, or it could mean that you forgot to migrate its row, his or her row. But if you express that the value is unknown, you are telling more to your future yourself or to a future developer that will look at the data in the database. Migration must be done in batches. You cannot update the whole table at once, because you would probably lock it, but you can do it in batches, or for example, 100 rows or 1,000 rows. Or you can write a PHP script that does each row separately. But I don't recommend migrate the whole table at once, because it can lock it, especially if the table is big. Next, we can make the column non-nullable. We can require now, the database can now require the value to be filled. And finally, we can deploy a new version of the application that reads the column. And we are done. So it's a little bit of a paradox, because in order to have zero downtime migrations, we have to deploy more often, which is not probably something that you have expected when going to this session. But it's also important to realize that when you are doing the first step, when you are adding the nullable column, you don't even have to have the next ones ready. You don't have to deploy it all at once, or as subsequent steps during a single session or in a single day. You can just prepare a single step of the whole process, and once it's done, you can start preparing for the next one. And great advantage of this is that this workflow is not blocking, because when you have a bigger team and you encounter a problem in a specific step of one feature from a single developer, you can continue deploying work from another developer while waiting for a fix from the first one. And if the migration is taking many hours to complete, you can still deploy different and unrelated changes to production. So typically, every single day, you are in different stages of multiple migrations at once for different features. Next, we can remove a column. So another advice is that it shouldn't matter if the affected table is too small or too big, if it's heavy used or marginal. You should always use these techniques, so you will learn how to handle them. Because when the day comes and you need to modify a table under big load, you will be ready and you will know how to do it. Next scenario is about removing a column. So if you realize that you no longer need some column in your database, and you should periodically clean columns that you no longer need, because you reduce technical debt this way, you first make it nullable, make it optional. And then you can deploy application version that stops using it. So no query, no select, no update, no insert, no longer mentions the column. And once this is true, you can drop the column. Next, if you decide that some column doesn't have an appropriate name, you can rename it. But you can't do it directly because you will break the application. The application only knows, in a single point of time, the application only knows about the first name of the column. So to have a column renamed, you need to combine the first and second scenario. So first you need to add the column with the new name and do all these steps, meaning that you have to add the nullable column, you have to fill in all past data, you have to set up the application that writes to the new column, and then you can run the steps for removing the old column. So you're combining two scenarios into one, and you run it one after another. Next, changing type of a column is very similar to renaming. So again, you add a column with a new type, with a new intended type, and you go through all the steps that requires you to add a column. And next, once you're ready, you can remove the old column. The drawback here is that you will end up with a column of a different type, but also a different name, but you didn't intend to do that. But you can again repeat the process because the old column is now removed, so you can add a column with the right type and the original name and repeat the whole process. But that's almost a cosmetic change because you already have the table in the state that you intended to have it in, but with a column with a slightly different name. I usually don't repeat the process to have the original column with the new type because I'm usually happy with the new name. I try to name it so that I'm satisfied with the new name. The easiest scenario is creating a table. This doesn't have any repercussions on the application. You can just do it. And this is also how you can extend your database schema if you are stuck with some older MySQL version and you can't perform non-logging alters on big tables. And I actually recommend this instead of creating new columns that you intend for them to stay nullable, because it leads to a better database design. And I have an example for you. So let's say that we have a table that combines anonymous and registered users. And we want to add columns that apply only to registered users. So one approach is to add nullable columns to the table. But that also means that someone with direct access to the database could add, or if you have some bug in your application, you would be able to add a column, add a row that doesn't have a valid combination of data. So registered user is required to have an email and a city they live in. But you would also theoretically write an insert that adds a user with an email, but doesn't add a city, which is a problem. So anywhere I see multiple nullable columns, or for example, multiple nullable parameters that are going into a method, I always suspect that only some nullability combinations are valid, which is also this case. We either want the user not to have both of email or and city, or we want them to have both of them. So the correct database design for this is to have a separate table that is specific for registered users. So you create a table that is joined by the same primary key, and you can afford to have all the columns in the separate table to be required. So now you cannot have any inconsistent data in your database. There's no way to insert an invalid row. But you have to realize that only some users will have a record in the second table. Okay. You can, until now I talk only about databases, but you can use similar principles to other client-server relationships. So for example, who uses Elasticsearch here? Yeah, quite a lot of people. So with Elasticsearch, you might also struggle with downtimes, but you can use the same steps to change the indexes, to change your documents, and stay online the whole time. So for example, if you want to add and use a key to your documents, you can first update mapping with the new key. Then you can deploy version that writes to the new key. Then you can reindex all documents. And finally, you can start using the new key, for example, in a sort or a filter. You can also stay online even if you are upgrading to a new version of Elasticsearch. So first, you can create a new node, a new server with the new Elasticsearch version. You can modify your application so that it writes the data to both nodes. Then you can write all past documents to the new node. And now you have two servers, two Elasticsearch versions that are identical, and you can use either of them, which means that between the steps 3 and 4, you can test your application that it works with the new Elasticsearch version, with the new server. And once you are sure, you can redirect all traffic to the new node. And if everything works as expected, you can stop the old node, and now you have upgraded Elasticsearch server without any downtime. So this is a very safe approach to this. But it will probably take a little bit more time, but it's very bulletproof and very safe. Another similar client-server relationship is if you have some kind of single-page JavaScript application, or you have some Ajax functionality on your website, and you can update the application continuously without users noticing or forcing them to reload. So for example, this is what Gmail does, because it's very common for Gmail users to have their Gmail window open for multiple weeks. So it would be really difficult otherwise, or very problematic to require them to reload their window, because it would disrupt their work. So if you want new clients to have some new capability, you can add a new key to export a JSON or XML or whatever your API uses. You can start reading the key in the new client, and then you can wait for all clients to upgrade organically when, for example, they restart their operating system, or they just close and open again their browser. And once you are sure that most of your users are on the new client version, you can stop publishing the old key. So all these approaches are very similar, and you can probably see the analogies between the database migration and these other kinds of migrations. Now, we can talk about zero downtime deployments. So application on the server has a lot of reasons to hang, to freeze during deployment, and I will tell you how to prevent them. So the first and most important thing is that deployments should be automatized. Deployment shouldn't be a complicated process. It should be just a single step. I especially like saying that deployment of a new version should be a project. It should be just a process. It should be just a single press of a button or execution of some kind of build script. To automatize your deployments, you can use Bash itself, or you can use some abstractions like makefile or think or end or something like that. And also, your build script that you are using for your deployments, you can probably reuse it for builds on your continuous integration server to verify that each of your commit works and isn't broken. And automatization also gives opportunity to add steps that will automatically happen every time during deployment and will improve stability of your application. So once you start automatizing something, you will find new stuff and new opportunities what you can also automatize. So you can probably start with a 3-step deployment, something like composer install and copy your files to the server and then switch to the new version. But you might end up with a 15-step deployment because you realize, now I can I can compile my template files. I can warm up some kind of cache. So having automation is really benefiting for you. Important thing to realize is that deployment has to be atomic. So in a single moment, new requests should be handled by should begin to be handled by a new version. So there shouldn't be any chance of any inconsistent state. Well, I have crossed Git, but of course you can involve Git in the process. But the website shouldn't be served right from the working directory of your Git repository and update it with Git pool, because when you are directly overwriting files in production, you don't give your application any chance to prepare it for the incoming traffic. So you cannot do the templates compilation and DI container compilation and stuff like that. And of course, the FTP approach is completely broken, and the update can take minutes, and you will leave your code inconsistent for a long time. So the fundamental way how to do this is called blue-green deployment, and it's a theoretical concept, and it can be applied in many ways. So the blue and green elements can be anything. There are various abstractions, but it's always some kind of identical environment. So the blue and green boxes can be either Docker containers or they can be host servers. And the idea is that your application runs from the blue one, and when you want to deploy a new version, you deploy it to the green one, and you start redirecting traffic from blue to green. And if you realize that the green one doesn't work, you can switch back to the old one, which you know that was working. But the concept that I have most experience with is running from a single or from multiple servers, but the blue-green boxes are actually represented by directories on a file system, which is why I will talk about this approach in depth. So the production folder, production directory is a symlink to the latest release. So it leads to one of the directories with the timestamp in the name, and with each new deployment, I create a new directory and prepare the application as much as possible for the incoming traffic. So before switching the symlink, I can do all the stuff that I already talked about. I can compile the DI container, I can compile template files, I can compile CSS and JavaScript with some preprocessors. And once my application is ready, I can switch the production symlink to a new version, and it will start receiving the incoming web traffic. There's a little bit of a problem with this, because by default, the symlink paths are not resolved. So if there's a request already handled in the middle of the deploy, your application might load a different version of the file than intended. So you probably don't expect it, but it happens. And it looks like this. Imagine that you are in the middle of a request. You are somewhere in the foo class, and you run some code that calls bar class to be autoloaded. But because the deployment happened at the same time, the bar class starts to be autoloaded from the new folder, which is a problem because it might be missing some kind of method that you called, or the method has another argument. So even if you tested each version separately, you probably didn't count that they would be combined in such a way. The solution to this is passing the right parameter to PHP-FPM, which will expand the symlink paths. So there will be no longer a surprise about what gets loaded, because the application sees the absolute path on the bottom, and it's no longer a problem because the application in this directory will only ask files from this directory and nothing else. But with this approach, you have one problem. Because of different file paths, your opcache will always cache the whole application again because it's in a different directory, in a different path. So the more deployments you do, the faster your opcache is getting full. One solution to this is to reload PHP-FPM from time to time, which is mostly fine, and we did for many years. We reloaded PHP-FPM once a day, but it limited us in the number of deployment we could do. We knew that we could probably do something about 20 deployments before our application was getting full and we started getting errors. The right solution to this, if you are running production in this way from different directories on the same server, and you are, for example, not using something like Docker, is to have two PHP-FPM pools, which is a better solution if you really can't afford any freeze-ups, because inherently reloading PHP-FPM means that some users will probably get 502 bad gateway errors. So this is a really cool solution. We have two PHP-FPM pools, and the production is always served by a single pool at once. So production is served from PHP pool number 1, and the other one is free to be reloaded. So you can reload it, and it frees up its memory. And so you can imagine that the first one is blue and the other one is green from the blue-green deployment. And once we deploy a new version, we switch their roles, and now the other one is available to be reloaded. So actually we have Nginx configuration, and we just update it, and we reload Nginx configuration, and this way we can utilize two pools at once. As a bonus, once you have two PHP-FPM pools, they can be used for warming up the opcache. So the one that's not in production, the one on the right, you can use it to call opcache compile file on each file from your application, but it has to be done through a web request, because the command line does not share the memory with the FPM pool. So you need some kind of private, not seen from the outside virtual host in Nginx, and you can use it to reload, to warm up your opcache. Why would we need something like this? Why do we need warming up the opcache? It's one of the main reasons why the server can struggle with the new application version. Because the file doesn't exist yet, it will be generated multiple times. So if we are already generating file ABC because of the first request, and someone else comes, the second request doesn't know that we are already in the middle of generating, and it starts generating again. So the server wastes time doing something that it wouldn't have to do with a different situation. So duplicate effort by the server can really clog up its resources, and it can really put a lot of stress on the CPU. And this applies not only to opcache, but also to generating code like templates or fetching data from the database. The same thing can happen there. I have a few notes about data caching. So the common mistake developers do is that they clear the cache with each deploy. But it isn't necessary, because the thing that you are clearing cache for might not have changed between the application versions. So by default, you should reuse the old cache from the old application version. Because if nothing related changes, you can reuse, you don't have to clear the cache, and it can be reused. And similarly, to a database migration, it's really hard to synchronize clearing the cache and the deploy of the new version, because it's hard to cache the right moment. So if you try to do it manually, or you try to synchronize clearing the cache and deployment, you will probably end up with some users getting the old cache with the new version of the application, or vice versa. So if you know that the new version of the application, if that something changed in the application, and you will have to clear a cache with the new deployment, you can just force it in your source code. You can change the cache key under which the cached value is stored, and it can be automatically emptied. It will be automatically empty on the new deployment. So this is really easy approach how to do this. And really advanced approach is, instead of letting cache expire, it's better to push the new data to cache. So there's no moment of regeneration and no moment of putting strain on the servers, because the cache, the value, the data in the cache are always there, because you always update it from the background. It's better than waiting for expiration, because then you will always have some users that will be very unlucky and will be given the request that is needed to refresh the cache, which takes inherently longer time than just reading the cache. And this is only needed for pages under really heavy load. It's mostly fine in most applications, in most pages, to just let it expire. But if you need it and you have some performance problems, you will know that you can use this approach. It's important to know about everything that happens in your application. So you should probably use some common storage for your logs, like services called Papertrail or Sentry, to gather your logs from all your servers. And so you can read it in the same place. But it's also important to realize that you shouldn't log errors only from your application, but also from your web server. Because when a request doesn't even reach PHP, because the PHP-FPM daemon crashed or something like that, your request will end up only at the NGINX layer, and your users will see HTTP 502 or 504, and you will not know about this error unless you set up logging of these errors in NGINX itself. And these errors are very common during deployments because of opcache related issues and higher load. So you really should set up logging in these situations on your web server. Okay, so you don't have to follow all of my advice at once. You should probably start with some basic points. And if your application and users demand it, you should improve your setup and work on it. So that's all from me today. You can contact me on Twitter or by email, and let me know if you need help in this area. Thank you very much. Please leave some comments and rating of this talk on JoinIn. Thank you. So, do you have any questions? Okay.
So does it work? Okay. Actually, I have two questions. The first one is there was many useful tips about SQL, about Elasticsearch, but I don't understand about the folders. Why need so strange and difficult structure of folders in production if you can just deliver your code with one container and you got versions? So if you got some stack, you can roll back to the previous version and it will take just a few seconds or less. I don't know. Why need so difficult structure of folders?
Yeah, of course, if you are familiar with Docker, with containers, and you know how you can run them, then yes, it's probably today the best solution. My experience comes from the fact that we had to solve this before Docker was a thing. So that's why I'm showing you this. And it's also difficult if you have a legacy application with tens of services on existing servers to migrate all to Docker. So yeah, that's why I was showing this. And my experience is that a lot of people still use this approach. So that's why I'm talking about this.
That's why you need to come back to the first slide where was about let's rewrite all.
Sorry?
I mean, if you have a legacy, let's rewrite all. Okay.
Yeah. It's not possible always.
The second question is, you have a slide about all builds should be automized. And after that, in a few slides later, you propose to choose manually clean cache or not. I think this is not a good idea because your builds should be automized, and if somebody who making deploy will forget about clearing cache, it will be trouble. But if you already will clean the cache, it will be trouble just for a first visitor, not for all.
Yeah, but it doesn't mean that it will be the trouble already for the first visitor, but maybe for hundreds of visitors before the cache actually gets populated. Yeah, but I wasn't saying that you should clear the cache manually. I was saying that you don't have to clean the cache with each deploy, and if the cache needs to be refreshed, you should actually express it in the code. So when you change the cache key, you will force the application to reload the data in the cache.
Yeah, but somebody can forget to change the key.
Yeah, that's a problem.
Yeah, and it will be not just a problem for a long period of loading your application for first visitors. It will be a problem that nothing will work, for example. And
yeah, but some applications can get really slow for a few minutes before all of the cache are updated.
Yeah.
But in that case, you are forcing to reload the whole cache if you are changing. It should probably be more granular. Sure. So we actually taught our HTML coder when he changes something inside the template, then he always looks for the cache macro and he updates the cache key. So yeah. Okay, but you could probably write something that just takes the hash of the HTML and makes a part of, or something like that. I don't know. Yeah. Yeah.
Yeah, and you can make after the build, you can run your application and then deliver container with loaded cache to the production. And
yeah, but it's hard to touch all the paths in the code with that. Yeah.
Okay, thank you.
Okay. So anyone else with a question? Okay, thank you very much.